All right, I want to add on to what Rob talked about in the video I showed you yesterday, the Mathematics video on dividing decimals, because I realized after I shared it with you that Rob uses long division for the computation. And that's a procedure that we hadn't really learned yet in class. So only a few of you who maybe already knew long division or your mom or dad taught it to you knew what he was talking about. In class, we had been focusing on partial quotients. Now, what he was talking about in terms of moving decimals and how that is the same as finding an equivalent fraction, all that stuff, that is all still true. He is correct, and it still works now. Only we're going to use partial quotients. You're probably going to use partial quotients because it's more familiar to you when it comes to dividing. So I want to just show you what he was talking about, his initial steps, his first steps, but how that looks when you use partial quotients. So what I have here on the screen is the same problem. This is the first problem you'll work on today in your work. So by watching this, you're actually getting that first problem done. Okay. And on one side of the screen, I have partial quotients. Okay. And on the other side of the screen, we got long divisions. We're going to take these one at a time. We're going to start with partial quotients first. Okay. So the problem says 25 and 85 hundredths divided by 1 1/10. And if we go back to what Rob was talking about, he said the first thing you want to do is make your divisor. Your divisor is the number that you're dividing by, 1 1/10, and make that a whole number. And the way we do that is by sliding the decimal one place to the right, like that. But since we moved our divisor one place to the right, we also have to move the dividends decimal one place to the right. He explained why, and he explained it in terms of fractions. Okay, so real quick, let me see if I can do this real quick. What he said was, remember, fractions are division. That was a whole lesson we learned back in Unit 3. This is like saying this problem, 25 and 85 hundredths divided by 1 1/10. Oh, can't get the decimals right. There we go. That's another correct way to write this same exact problem because fractions are division. And so what we're doing when we slide this decimal one place to the right 2 times, right, is we're finding an equivalent fraction. And the fraction we're finding that's equivalent is so that we can have a decimal that is a whole number. And how do we make 1 1/10 a whole number? Well, we multiply it by 10. And if we multiply 1 1/10 by 10, we get 11. And that's a whole number because our base 10 system and our decimal number system is based on 10. So 1 1/10 times 10 is 11. That's what we've done here by sliding the decimal over one spot. We have now 11. But because this is a fraction, we have to do the same exact thing to the top number, the numerator. We also have to multiply it by 10. That's how we find equivalent fractions, right? We multiply both top and bottom number by the same number. And so what we've done is we've made 1 1/10 11. I'm trying really hard to make a decimal. There we go. And we made 28 and 85 hundredths, 285 and 5/10. That's an equivalent fraction. So that's all we're doing here. So let me get rid of that. That's the rationale, the math reasoning behind why, there we go. Okay. We're moving decimals. Now, when it comes to partial quotients, as review, we first draw our partial quotients line down the right-hand side of the problem. And we're now ask ourselves, okay, we got to take these now for a moment. We're going to take this as like one big number divided by another number. So we're just going to pretend for partial quotients purposes that this is 2,585 divided by 11. About how many 11s are there in 2,585? Okay, I'm just taking both numbers, the number inside the division symbol and the number outside as like entire numbers. And that's what we're going to have to do for partial quotients. And that's why I'm going over this with you now. So we ask ourselves, are there at least 100 11s? Well, let's see, 100 times 11, that would be 1,100, right? Oh, we can go bigger than that. What about 200 11s? That'd be 2,200. Let's do it. 200 11s. So 200 times 11, that'll be 2,200. Okay. And we'll subtract that away. So let's go ahead and start subtracting. 5 minus 0 is 5. 8 minus 0 is 8. 5 minus 2 is 3. And 2 minus 2 is 0. So that leaves us with 385. We ask ourselves again, same question now. How many 11s are there in 385? Well, let's see. 11 times 10, Oh, math fact. Thank you, Reflex. That's 110. So how about 20 11s? That'd be double that, 220. Ooh, 30 11s. That'd be 330. Ooh, let's do that. Let's do 30 11s. I'll write my other partial quotient, 30 there. 30 times 11, that's 330. We'll subtract that away. And we'll get, let's see, 5. We'll get 55. Thank you, Reflex Math. One more time. 11 times what is 55? That's right, 5. 5 times 11 is 55. We'll subtract that. We'll have no remainder. Perfect. Now, let's add up our partial quotients. 200 plus 30 plus 5 is 235. So we write our answer on the answer line, 235. And now, just like Rob said, he was right again in the Math Antics video. We take the decimal where it is, and we move it straight up into the answer line. We put it right there. Let me make that in black so you can see it. We put it right there. And our final answer is 23.5, or 23.5. And if we go back to the very original question, right? So let's jump over to the other side for a second so we can see it clearly, because this is the same question. 25 and 85 hundredths. Well, that's almost 26, divided by a little bit more than 1. We should expect that answer to be right around 26, right? Because 26 divided by 1 would be 26. So 23.5 is kind of close. So we are in the ballpark. That is correct. It makes math sense. So that's how you do this problem using partial quotients. I hope this helps. Now, the way Rob did it using long division looks like this. I'm over here to the right now. We're still going to move our decimals, right, to find those like virtual equivalent fractions. All right, one place to the right. So we have to do one place to the right with our dividend. Okay, now we ask ourselves how many 11s, we'll pretend this is 11, the divisor, are in 2. And there are no 11s in 2, so how many 11s are in 25? 2. So we'll write, let me do my work in blue here. We'll write 2 11s. That's the divide step. That's a D. And then we'll multiply. That's the M. Multiply. 2 times 11 is 22. We'll subtract that. We'll get 3. We'll bring down our next number, 8. We repeat. We subtracted. And then we brought down. So divide, multiply, subtract, bring down. Those are the 4 long division steps. Now again, if you hadn't learned this yet, don't worry. It's just review for those who have learned it. I'm not trying to teach you long division. I'm just trying to show you what Rob showed you, okay, in case you already know it. Now we repeat the steps. Okay, we go back to the beginning. We've brought down our next number. Now we go back to divide. How many 11s are in 38? Well, let's see here. Let's go with a different color. There are 3 11s in 38. So we'll multiply next. 3 times 11 is 33. We'll subtract that number. We'll get 5, and we'll bring down our next number. We'll put 5 there, 55. Now, we'll go to our next step. All right, how many 11s are in 55, right? So we'll divide, that's 5. Look at that, the same 3 digits, 2, 3, 5. 5 times, multiply. 5 times 11 is 55. We'll subtract, and we'll get 0. And there's nothing left to bring down, so we're done. And then we move our decimal straight up into our answer line. That's where it goes, right there. And look at that, we get the same answer, 23.5, or 23.5. That's long division. But again, I'm not teaching you long division. I'm just going over what Rob showed you in case it does make sense to you. This right over here, folks, is what we've been doing, partial quotients. So stick with that, okay? You got 4 more problems to try on your own today. Good luck, and let me know if you need help. I'm here to help. We can have a meet, and we can work on them together. Okay? All right. Thanks for watching, and work hard.